Good morning, friends. Now, in our chapter number 12, Electromagnetic Induction, in this chapter, we have studied our new topics transformer. Mutual inductance is the basis of all types of transformer. A transformer is a device used for changing the voltage of alternating current from low value to high value or vice versa. Whenever the magnetic field linked with a coil changes, an EMF, that is electromotive force, is induced in the neighboring coil. Then in the transformer there are two coils. First are primary and secondary. It is insulated from each other and wound on a soft iron core. The primary and secondary coil are called input and output coil respectively. When an AC voltage is applied to primary coil, the current through the coil changes sinusoidally, causing similar changes in the magnetic flux through the core. As changing the magnetic flux is linked with both primary and secondary coils, then the electromotive force is induced in each coil. That is, Np and Ns be the number of turns in the primary and secondary coil respectively. Then at the instant of time t, the magnetic flux linked with primary coil, that is phi p, is equal to number of turns of coil Np phi, and secondary coil phi s is equal to number of turns of secondary coil Ns phi. The induced EMF in primary and secondary coil will be, we can get the equation small ep is equal to minus d phi p upon gt is equal to minus np, that is number of turns of primary coil d phi upon gt, and then es is equal to minus d phi s upon dt is equal to minus ns d phi upon gt. Then we have get the equation es upon ep is equal to ns upon np. The ratio of ns upon np is called turn ratio, that is also called as a transformer ratio of the transformer. For ideal transformer, input power is equal to output power, that's time ep ip is equal to es is. Then we have get the equation es upon ep is equal to is upon ip. Then es upon ep is equal to ns upon np, that is equal to ip upon is. There are some cases it will be arises. For first case, when number of turns of secondary coil it is greater than to the number of turns of primary coil, then es it is greater than ep, that is the step up transformer, and ip it is greater than is, the current in the primary coil is more than that of in secondary coil. In second cases, when number of turns of secondary coil it is smaller than number of turns of primary coil, then es is smaller than ep, that is the transformer is step down transformer, and ip is smaller than is, then the current in the primary coil it is less than in the secondary coil. Here the energy loses in a transformer, that is copper loss in Heat is produced due to the resistance of copper winding of primary and secondary coil when current flow through them. This can be avoided by using thick wire for winding. Second, energy loss in transformer, flux loss, that is, in actual transformer, coupling between primary and secondary coil is not too perfect. So, a certain amount of magnetic flux is wasted. That will linking can be maximized by winding the coil over the other. Here it is the transformer.